Or, in passing, I want to continually mention it in passing over my Catholic school upbringing. I like continual exposure to ideas. Why do you have to put the margin of error on there? Why is there a margin of error? Either in those words or your own words.
People lie.
Oh, careful. That's a strong statement. People lie. Let me ask you a different way. Oh, Tony, go.
Sampling error?
There is what's called sampling error that happens. And that sounds like a bad thing, but it's a random thing. It's not bad or good, it just is. If I was to grab 60 more of my Facebook friends from my population, would there be exactly 22% of them that have more friends than me just like this time? Probably not. Would they be close if I drew a perfectly random sample? That's a trickier question. It's easy to say they wouldn't be exactly the same. But it's hard to define what close is. So what helps you define what close is? The margin of error helps you define what close is. Now, it's a pretty wide margin, 10%. That's because your sample is only 60. Somebody asked me, I forget who it was, about 2 weeks ago, is there a way to calculate margins of error? Yes, there is, happily. And if you want to see it at Brig, I'll happily show it to you. It's a really fun little calculation. It's 244 basically. But you would have to put 10% on that 22. So, let's complete the shaded boxes. I should not tell people that 22% of my Facebook friends have more friends than I do. I should tell them, however, the percentage of Sean's Facebook friends who have more friends than he does is at least 12. About 12%. 10% below 12, below 22 is 12. Does that make sense? And we go 12%. And at most, 32. You see, we do the 10%, it's a plus or minus. Remember the plus or minus from the Alaska oil drilling from the Gallup poll from a couple weeks ago? Yes? Don't, they're not going away. They're hugely important. I got a quiz coming for margins of error again, because they're that important. Margins of error need to be applied to sample data. You have to, because the chance that you exactly caught your parameter is essentially zero, like you guys just said. Fair enough? And now, I think we just answered the next question, but the question right after this, if you look at all my friends, you'll see that about 24%. So what I did was, I went back into all of my 673 Facebook friends, copied them into Excel, did the COUNTIF trick, and as it turns out, it's not 22%, it's 24%. How'd you guys do in your sample? Pretty damn good. Were you within a margin of error? Yes, you were within a margin of error, and that's the goal of inferential statistics, to be within a margin of error. If you're within a margin of error, we call that success. Because you got close enough. That's the idea of close enough. We're actually within 2 percentage points. Now, the reason, Aaron, I like that look, you're like, wait a minute, what the hell are you doing? The reason it's a little bit fictitious, yes? Because what I had done is I actually drew a sample for my population where I could have actually done the entire population. Now, you can always draw a sample from a population. Can you always know your population's measure? That's the trick, right? You hardly ever can know your population's measure, except in fictitious cases like this, where they're sitting in front of me on a page. Very often you want to know things like, what's the effect of a medication on ADHD in 12 to 14-year-old middle school boys? You don't know the population of that. You have no idea. Well, you know there's a lot of them, but you can't measure them all. Because by the time you're done measuring, some of them aren't middle school boys anymore, and there are some more that have flushed in, and the whole population has changed. So you draw a sample. The idea isn't that you know the 24 is there, it's that we got really, really close to it with our sample. That's the point, yes? Even with those goofy outliers, we got close to it. Pretty stoked. You should be stoked too. Why is the percentage a little bit easier for me to swallow as a statistician than the average in this case? Why is the percentage easier? Remember, we kind of poo-pooed the average after we saw this beautiful graph. We kind of poo-pooed the average a little bit because the data was skewed. It's not bell-shaped, it's highly skewed, thank you. Highly skewed, not bell-shaped. How does the percentage ignore the skewedness? I haven't taught you this, FYI, I haven't taught you this. Because there's no such thing as an outlier with a percentage. Either you have fewer friends than me, or you have more. You could have the same number of friends, no, that didn't work out for anybody. But it doesn't matter if you have 674 friends or 20,000 friends. You have more friends than me. It doesn't matter how far. It just matters that you're above me. And it doesn't matter if you have 672 friends Or if you have 0 friends. Well, yes, you couldn't have 0. You have at least 1, me. Right? So it doesn't matter if it's 1 or 672, you have fewer. So in other words, the average actually measures the distances between each of the data points, which is what the standard deviation is, yes? Average distance between average and the data. Whereas a percentage just says, which side is it on? That side or that side? Quick sort, quick sort, quick sort. There's no such thing as an outlier in that respect. There's no such thing as an outlier. Because there can't be. Outliers are based on how far from average you are. Yes? It's one way of deciding. Good? Excellent. Whew. I think we answered this next question. Why must the margin of error, MO, be attached to the sample proportion? How come? Sampling error. I love those 2 words. Sampling error. Is sampling error bad?
No.
It just is. Love that. It just is. It's going to happen. You're always going to have sampling error when you do a sample because you're not going to capture the entire population, which means you're always a little bit uncertainty. You can have less uncertainty by sampling more people. That's pretty much an intuitive notion. If I sample more people, the one that's not well, it's going to knock down my sampling error. But you can never have 0 sampling error because you're always going to have some uncertainty in your sampling. Cool! Make sense? We happy with these? That's a lot of ideas. That's a lot of ideas. In some schools, that's the entire 243 Stat 1 course right there. They stop with that. I call that a crime. That's my opinion, but whatever. Let's take 5 right now, yes? We're about that time anyway. Let's take 5, get back into some different data sets.